Dear students, in this paper of forensic chemistry and explosive, let us continue our study further. In the previous modules, we have learned about the various types of beverages which are alcoholic and non-alcoholic, and then focusing on the alcoholic beverages, we have also studied about the fate of alcohol in human body, how the alcohol intoxication happens, and how the breath alcohol estimation is done. In this module, we shall continue this study and study about how the alcohol in blood is estimated. So, dear students, after studying this module, you shall be able to know how to collect the different biological samples for the analysis of ethyl alcohol, that is ethanol, and you will be able to know how to extract the ethyl alcohol from biological materials, and then what are the different tests that can be used for the chemical analysis of alcohol. And you shall be able to become familiar about the different instrumental techniques that are generally employed in the analysis of ethanol. So, let us begin with knowing the blood alcohol content, which you have been made familiar earlier also. The blood alcohol content, that is BAC, is also called as blood alcohol concentration or blood ethanol concentration or blood alcohol level. And when we talk about the blood alcohol estimation, it is most commonly used as a metric of alcohol intoxication for the legal and medical purposes. The blood alcohol content is the legal name for BAC, but blood alcohol concentration is also very often used for the simpler description. So, you should be familiar about all these terms so that you can relate what is being talked about and how precisely it has to be calculated. Going further, blood alcohol content is usually expressed as a percentage of ethanol in the blood in units of mass of alcohol per volume of blood, or alternatively it is the mass of alcohol per mass of blood. That is, there are two ways, either you have mass of alcohol per volume of blood or you have mass of alcohol per mass of blood. For purposes of law enforcement, blood alcohol content is used to define intoxication and provides a rough measure of impairment. Although the degree of impairment may vary among individuals with the same blood alcohol content, it can be measured objectively and is therefore legally very useful and is difficult to contest in court. Each country or state may define the BAC differently. This you should be very familiar. Since measurement must be accurate and inexpensive, several measurement techniques are used as proxies to approximate the true parts per million measure. The number of alcoholic beverages or drinks consumed is often a poor measure of blood alcohol content because of variation in sex, body weight and body fat of the person who is consuming. All that will be depending upon the number of the alcoholic beverages which are consumed and what will be actually the alcohol content inside his or her body. So, dear students, with this background, in this module, let us go into more detailed study with the help of graphics and visuals, and here you shall be dealing about how the sample collection is done, how the extraction of ethyl alcohol from biological materials is done, and then what are the various chemical analysis of ethanol. One we have is the iodoform test, next is the sulfomolybdenic acid test, then there is a ethyl benzoate test, and then we will see how the determination of ethyl alcohol in blood or urine is done. And here we have the Kojelka and Hine or Cavett method, Then we have the Widmark's formula. Also we will deal about the instrumental technique of analysis of ethyl alcohol, where gas chromatography will be of special emphasis.
Sample collection. In the cases of suspected deaths due to alcoholic intoxication, viscera is collected and preserved in saturated saline. Special attention must be paid in the preservation of these samples, otherwise it would put the whole examination in vain. In cases of suspected intoxication, samples of blood and urine are generally collected. Before the suspect's skin is punctured with a sterile needle, it must be cleaned by a swab of a non-alcoholic disinfectant like aqueous mercuric chloride, aqueous benzalkonium chloride, aqueous benzalkonium chloride, also called Zapiran, etc. The use of an alcoholic disinfectant may either give false positive results or may contribute to falsely high alcohol contents of blood. About 5 to 10 ml of blood sample must be collected in a test tube and must be stored in a refrigerator, usually at 4 degrees Celsius, after adding the anticoagulant like EDTA, potassium oxalate, etc., and preservative like sodium fluoride. The addition of anticoagulant will prevent clotting and the preservative will inhibit the growth of microorganisms which are capable of destroying alcohol. The urine sample is also collected in the usual manner and preserved with 30 mg of phenyl mercuric nitrate for every 10 ml of urine. The relevance of any finding in the field of forensic is determined in the first instance by the nature and integrity of the specimens submitted for analysis. This means that there are several specific challenges to collect and select specimens for ante-mortem and post-mortem toxicology investigation. Post-mortem specimens may be numerous and can endure some special difficulties compared to clinical specimens, namely those resulting from autolytic and putrefactive changes. Storage stability is also an important issue to be considered during the pre-analytic phase, since its consideration should facilitate the assessment of sample quality and the analytical result obtained from that sample. The knowledge on degradation mechanisms and methods to increase storage stability may enable the forensic toxicologist to circumvent possible difficulties. A blood alcohol test measures the amount of alcohol in your body. Alcohol is quickly absorbed into the blood and can be measured within minutes of having an alcoholic drink. The amount of alcohol in the blood reaches its highest level about an hour after drinking. But food in the stomach may increase the amount of time it takes for the blood alcohol to reach its highest level. About 90% of alcohol is broken down in the liver. The rest of it is passed out of the body in urine and the exhaled. Alcohol has a noticeable effect on the body, even when consumed in small amounts. In large amounts, alcohol acts as a sedative and depresses the central nervous system. Blood alcohol content, also called blood alcohol concentration, blood ethanol concentration, or blood alcohol level, is most commonly used as a metric of alcohol intoxication for legal or medical purposes. Blood alcohol content is the legal name for BAC, but blood alcohol concentration is sometimes used for simpler description. Blood alcohol content is usually expressed as a percentage of ethanol in the blood in units of mass of alcohol per volume of blood or mass of alcohol per mass of blood, depending on the country. Extraction of ethyl alcohol from biological materials. Ethyl alcohol is isolated from biological materials by acid distillation. Viscera, vomit, stomach contents, and other materials should be analyzed separately. 50 to 100 grams of viscera, finely minced, should be brought into the consistency of a thin gruel by adding 3 to 5 times of distilled water and then acidified with sulfuric acid and submitted to steam distillation. The apparatus of distillation consists of a conical flask which contains the sample added with distilled water and sulfuric acid. A connector fixed to the mouth of the flask connects the flask to the condenser. The condenser is connected with a water inlet pipe and water outlet pipe for the cooling purpose. Then, finally, on the other end is the receiving flask, where the distillate is collected. This distillate is used for the color tests and for instrumental analysis as well. When the sample is heated, its vapors pass into the condenser tube, which is being cooled simultaneously because of the water supply. The vapors gets condensed due to cooling effect and get collected in the receiving flask in liquid form. The liquid collected is called distillate. The distillate must be stored carefully and properly covered as there are possibilities of various metals, acids, and other compounds to escape if left uncovered. Also, this distillate must be kept away from different chemicals and high temperature as it may lead to undesirable changes in the sample and lead the experts towards misleading results. Distillation can also be carried out by heating a round bottom flask fixed with a condenser on its mouth. The flask containing the material or the sample should preferably be heated on the water bath. The condenser and the receiving flask should be well cooled with ice, especially in hot season. The outlet of the condenser should be dipped in little water or sodium hydroxide solution. A few pieces of pumice stone may be kept in the flask to prevent bumping. It is better to collect the distillate in 4 to 5 fractions, out of which the first one should not exceed 20 ml and the remaining fractions should be 50 ml each. The distillate contains alcohol and other volatile acids, etc. Chemical analysis of ethyl alcohol. The following tests are to be carried out for the detection of ethyl alcohol in the exhibits. Iodoform test. Take 1 ml of the distillate and add a few drops of 10% sodium hydroxide to it. This is followed by dropwise addition till the solution becomes brown. The mixture is warmed on low flame or water bath for few minutes. A few drops of iodine solution are added to change the color of the solution from brown to yellow. The mixture is again heated on low flame or water bath. Yellow color precipitate is formed on standing. The precipitate is observed under the microscope. Characteristic hexagonal crystals of iodoform are seen. It is also positive in presence of acetaldehyde, isopropanol, which on standing for long time breaks into flower-like structure. This test initially involves the process of oxidation followed by substitution and finally hydrolysis. When a few drops of alcohol are warmed with iodine and sodium hydroxide, then yellow precipitate of iodoform with a characteristic smell is obtained. All alcohols having the presence of CH3CH-OH group gives positive results for iodoform test. Since the reaction takes place with alkali solution as one of the reagents, hence some alkyl halides will also give positive for this test. Mechanism of iodoform reaction. Step 1. Hydroxide functions as a base and removes the acidic alpha hydrogen giving enolate. Step 2. The nucleophilic enolate reacts with the iodine giving the halogenated ketone and an iodide ion. Step 3. Steps 1 and 2 repeat twice yielding the trihalogenated ketone. Step 4. The hydroxide now reacts as a nucleophile at the electrophilic carbonyl carbon with the double bond becoming a single bond and the oxygen is now anionic. Step 5. Reform the favorable C double bond O and displace a leaving group, the trihalomethyl system, which is stabilized by the three halogens. This gives the carboxylic acid. Step 6. It is an acid-base reaction. The trihalomethyl anion is protonated by the carboxylic acid, giving the carboxylate and the haloform, that is, trihalomethane. Sulfomolybdic acid test. In this test, 1 gram of molybdic acid in 25 ml of concentrated sulfuric acid constitutes the reagent. 2 ml of hot reagent is added to 2 ml of distillate. A deep blue ring appears at the junction of two liquids. On shaking, the whole mixture becomes deep blue. This blue color indicates the presence of ethyl alcohol. This test is very sensitive and is negative with acetone, acetaldehyde, and dilute solution of methyl alcohol. Strong solution of methyl alcohol gives only a light blue color after several minutes. Ethyl benzoate test. To conduct this test, add 2 drops of benzoyl chloride to 2 ml of the distillate or the sample. The mixture is made alkaline by adding 10% sodium hydroxide drop by drop. On warming, irritating smell of benzoyl chloride is replaced by sweet fruity odor of ethyl benzoate. Methyl alcohol also gives this test, but it does not give the iodoform test. Various methods of determination of ethyl alcohol in blood and urine. In the cases related to drunkenness, detection of alcohol in body becomes very important. However, the best method is to note the behavioral abnormalities of the suspect. But the presence or absence of alcohol can only be confirmed by analyzing the breath, blood, or urine. The analysis of breath can be performed on the spot with the help of breath analyzer instruments like alcosensor. Breath analyzers do not directly measure blood alcohol content or concentration, which requires the analysis of a blood sample. Instead, they estimate BAC indirectly by measuring the amount of alcohol in one's breath. To measure alcohol, a suspect breathes into the device. The breath sample is bubbled into one vial through a mixture of sulfuric acid, potassium dichromate, silver nitrate, and water. The principle of the measurement is based on the following reactions. Sulfuric acid removes the alcohol from the air into a liquid solution. The alcohol reacts with potassium dichromate to produce chromium sulfate, potassium sulfate, acetic acid, water. The silver nitrate is a catalyst, a substance that makes a reaction go faster without participating in it. The sulfuric acid, in addition to removing the alcohol from the air, also might provide the acidic condition needed for this reaction. During this reaction, the reddish-orange dichromate ion changes color to the green chromium ion when it reacts with the alcohol. The degree of the color change is directly related to the level of alcohol in the expelled air. To determine the amount of alcohol in that air, the reacted mixture is compared to a vial of unreacted mixture in the photocell system, which produces electric current that causes the needle in the meter to move from its resting place. The operator then rotates a knob to bring the needle back to the resting place and reads the level of alcohol from the knob. The more the operator must turn the knob to return it to the rest, the greater the level of alcohol. However, the alcohol content of the blood could be determined by using modified version of Kozelka and Hein-Cavett method. Kozelka and Hein-Cavett method. Cavett test or Kozelka and Hein test. This method involves aeration with distillation or diffusion under low pressure to determine alcohol in blood, where potassium dichromate is used, which oxidizes alcohol to acetic acid. Each ml of dichromate solution reduced is equivalent to 0.575 mg of alcohol. The basic principle behind this method is that alcohol is easily oxidized to acetic acid in the presence of oxidizing agents like potassium dichromate and sulfuric acid. So, each ml of N by 20 potassium dichromate solution that is reduced in this process is equivalent to 0.575 mg of alcohol. Windmark's formula. Windmark has given simple formulas to estimate the amount of alcohol present in the body. For blood analysis, the formula given is A is equal to CPR. Here, A is equal to total amount of alcohol absorbed in the body, P is the weight of the person, C stands for concentration of alcohol in the blood, and R is a constant, namely 0.68 for men and 0.5 in women. For urine analysis, the formula used is A is equal to 3 by 4 qpr. Here, A is the total amount of alcohol absorbed in the body, P is the weight of the person, Q is concentration of alcohol in urine, and R is a constant, namely 0.68 for men and 0.5 in women. Instrumental technique of analysis of ethyl alcohol. Gas chromatography. Gas chromatography or GC is a common type of chromatography used in analytical chemistry for separating and analyzing compounds that can be vaporized without decomposition. Typical uses of GC include testing the purity of a particular substance or separating the different components of a mixture. The relative amounts of such components can also be determined. In some situations, GC may help in identifying a compound. In preparative chromatography, GC can be used to prepare pure compounds from a mixture. In gas chromatography, the mobile phase or moving phase is a carrier gas, usually an inert gas such as helium or an unreactive gas such as nitrogen. The stationary phase is a microscopic layer of liquid or polymer on an inert solid support inside a piece of glass or metal tubing called a column. The instrument used to perform gas chromatography is called a gas chromatograph. The gases compounds being analyzed interact with the walls of the column, which is coated with a stationary phase. This causes each compound to elute at different time known as the retention time of the compound. The comparison of retention times is what gives GC its analytical usefulness. Gas chromatography is in principle similar to column chromatography as well as other forms of chromatography such as HPLC and TLC, but has several notable differences. First, the process of separating the compound in a mixture is carried out between a liquid stationary phase and a gas mobile phase, whereas in column chromatography, the stationary phase is a solid and the mobile phase is a liquid. Hence, the full name of the procedure is gas liquid chromatography, referring to the mobile and stationary phases respectively. Second, the column through which the gas phase passes is located in an oven where the temperature of the gas can be controlled, whereas column chromatography has no such temperature control. Finally, the concentration of a compound in the gas phase is solely a function of the vapor pressure of the gas. Numerous methods have been described for the determination of ethanol in whole blood, serum, and urine, the most popular being gas chromatography. The sample is injected into a heating chamber. Due to high temperature of the chamber, alcohol is converted into vapors which are carried by an inert carrier gas, usually nitrogen, through a column packed with our suitable adsorbent material. Different components of the sample get separated on the basis of their differential affinity towards the stationary adsorbent phase, which are later on detected by a sensitive detector. A chromatogram obtained helps in qualitative as well as quantitative analysis. Position of the peak is representative of a particular compound, and the area covered by the peak represents its amount. Operating conditions: column Porapack polymer bead 8 to 100 mesh or its equivalent, which can separate or resolve ethanol. Column temperature 160 degrees Celsius. Carrier gas nitrogen. Rate of gas flow 50 ml per minute. Detector flame ionization detector. Alternating operating conditions: column 0.3% carbovax 20 m on 80 to 100 mesh carbopack C 2m into 2 mmID or its equivalent. Column temperature 35 degrees Celsius for 2 minutes and then programmed at 5 degrees Celsius per minute to 175 degrees Celsius and hold for at least 8 minutes. Carrier gas nitrogen at 30 ml per minute.
So, dear students, in this module which dealt with the testing of alcohol in blood sample or the biological samples in general, we studied about how about 5 to 10 ml of blood sample must be collected in a test tube and must be stored in refrigerator, usually at 4 degrees centigrade, after adding the anticoagulants like EDTA, potassium oxalate, etc., and the preservatives like sodium fluoride. This is very important, otherwise the sample will get destroyed. We also studied the urine sample is also collected in the usual manner and it is preserved with 30 milligrams of phenyl mercuric nitrate for every 10 ml of urine. Then we studied how the ethyl alcohol is isolated from biological materials by acid distillation and then confirmed by the test like iodoform test, sulfo-molybdic acid test and the ethyl benzoate test. After that, we studied that the concentration of alcohol in blood and urine is determined by Kojelka and Hein or Cavett method, which could further be confirmed by gas chromatography. Thank you.